All right, so I think this is recording. Let's take a look here at number 7. We're dividing two rational expressions. They want us to just to write it as a single rational expression in lowest terms, and also to state any restrictions that we have. Now, our Google Documents doesn't always like Microsoft, our Microsoft Equation Editor. Um, you can see that it extends the fraction bar and kind of, I believe that you can read it though. All right. In division problems, you have to be very careful because when you state your restrictions, and in arithmetic, our restrictions, well, there's two of them. If we had any square roots, and we don't, we have to make sure that we never take the square root of a negative number. That's a common restriction. And the other restriction that we're dealing with here is when you have a variable in a denominator, you have to make sure that the value of that variable doesn't cause division by zero. Division by zero is undefined. Our denominator, we have to make sure that our denominator will never equal zero. All right, so let's look at these denominators and write them in factored form. So let's come off to the side and let's look at 8b plus 20. If I rewrite 8b as 4 times 2b, and if I rewrite 20 as 4 times 5, it should be obvious that 4 is common to both terms, and we can factor out that common factor, and we have now a binomial 2b in the first term and 5 in the second term. If we look at this 4b plus 10, and if we rewrite each term, if I rewrite 4b as 2 times 2b, and if I rewrite 10 as 2 times 5, you can see that a 2 is common to both terms, and you can factor out that common factor, and you have 2b and then plus 5. All right. Now, since we're factoring, let's go ahead and look at this numerator that's a trinomial. 1b squared minus 2b minus 15. And the method that we use most of the time to factor our trinomials, unless it's a perfect square time trinomial, we notice it is the x method here. Negative 2b is our middle term, and our first times our last is negative 15b squared. So now through trial and error, we'll look for two expressions that when multiplied together give us the top, and when added together give us the bottom. And 3b times a negative 5b, I think does the trick, because when you multiply them together you get the top, and when you add you get the bottom. So we can take a shortcut. Whenever we see a leading coefficient of 1, when the number in front of b squared is a 1, it's a lot easier factoring problem because we don't have to make a table. We can just come in and take a shortcut and use the 3 and use the negative 5. All right, so let's come back to our problem. Our first numerator here, we just got done factoring that trinomial. We've got it to be b plus 3 times b minus 5. This denominator, 8b plus 20, that's where we started up here, and we have 4 times 2b plus 5. The 2 is just a single factor of 2. The 4b plus 10 was 2 times 2b plus 5. Now I'm going to erase this work over here just to give me some room. So in factored form, it's very easy now to look at my denominator and to see what my restrictions are. This 2b plus 5 is the only factor that has a variable in it, and this is the same factor, 2b plus 5, and we have to make sure that 2b plus 5 is never equal to 0. So you actually temporarily set it equal to 0 and solve the equation, and then you say to yourself, well, if I want this 2b plus 5 to never equal 0, then I want b to never equal negative 5 halves, and there's my restriction. All right, so I leave this first fraction alone. I don't do anything to it yet. Now, if I did see a common factor within this fraction, I could simplify it if I wanted to, but I don't. I'm going to change this division to multiplication. So now I take the reciprocal, I flip this fraction my divisor. So the 2 times 2b plus 5 now comes up to the numerator, and this 2 comes to the denominator. Well, sometimes this numerator might be a complicated expression. It might have a b in it, and maybe that adds to our restriction. Now, in this case, it doesn't, because 2 is not 0. 2 will never become 0 unless you multiply it by 0. So we still have the same restriction. But very often you have to add more to this restriction because of this new denominator. So now we've got two fractions. Let's write it as a single fraction by multiplying the numerators together and multiplying the denominators together. So since I can multiply in any order, I like putting my single factor of 2 at the beginning. And then I've got b plus 3 and b minus 5 and 2, oh, I lost my b, 2b plus 5. Now in the denominator, I'm going to write that single factor of 2 first, and then this factor of 4, and then this 2b plus 5. Now I can't lose my restriction. I would never be able to multiply these two fractions together if b were allowed to equal negative 5 halves. All right, let's look and see if we have common factors. I see a 2 divided by 2, and I know that's 1, so we say that cancels. I have another factor over here, 2b plus 5 times divided by 2b plus 5. Now that looks to be the only common factors. So in the numerator, I have b plus 3 times b minus 5. And in the denominator, I just have a single factor of 4. And of course, our restriction is that b cannot be negative 5 halves. And I'm just going to leave this in factored form. Sometimes you'll see that sometimes you'll be asked to multiply these two binomials together. But in factored form, it gives us a lot of information. That's why we spend so much time learning how to factor. I'm just going to leave my final answer like this. And I hope that helped. All right, well, I'll talk to you later. Bye.